Number 5 from the practice problems asks us to find the intervals where the graph is concave up or concave down, as well as find inflection points. Concavity, inflection points, I'll deal with the second derivative. That is when we set our second derivative equal to 0. So we're going to find the second derivative, which would be negative 3x squared minus 12x minus 9 for the first derivative. Our second derivative is negative 6x minus 12. Points of inflection always occur when the second derivative is equal to 0 or undefined. So set that second derivative equal to 0 and solve for x. We need to see, does the concavity actually change at x equals negative 2? So we are going to set up a chart, an interval chart. Our x is from negative infinity to negative 2 and negative 2 to infinity. And we are plugging into the second derivative. So if I plug in negative 3 into the second derivative, that gives me 18 minus 12, which is positive. If I plug in 0, I get negative. So we do have a sign change at x equals negative 2, which means I do have an inflection point when x is negative 2. To get the y value of that inflection point, we are going to plug negative 2 into the original function for x. So our y value is 0. So we have a point of inflection at negative 2, 0. That is our answer to part B. Part A wants the intervals where the function is concave up or concave down. Concave up just means second derivative is positive. So we are concave up when the second derivative is positive, which is negative infinity to negative 2. And concave down when the second derivative is negative, which is negative 2 to infinity.